Hi, in this video we'll be making a single phase half bridge inverter circuit using IGBT diode. The final output voltage of a single phase half bridge inverter should be half of the source voltage. So let's start making the circuit. Open the Simulink library either by clicking on the Simulink library given in the home bar section or by typing Simulink on the command window and press the enter button as shown in the video. Now, open a Simulink model by clicking on the new plus sign in the home bar. To make the inverter circuit, we need the following components. So for this, let's go to the Simulink library, then to the Simscape, SimPower System, Specialized Technology, and to the fundamental blocks. Click on the electrical source, click the DC source, and drag it to the model page. From the element section, select and drag the ground and series RLC branch to the model page. Go to the measurement section and add the voltage measurement block to the model page. As the IGBT diodes are power electronic components, this can be found in the power electronic section. Now, we need a pulse generator to keep the gate signal to the IGBT. Go to the search section and search to find the pulse generator. Similarly, search for scope and power GUI and add it to the model page. As we have collected all the required components, let's start aligning and making the circuit for the inverter. This is how the circuit should look like. Now, let's start to assign values for each of the components. Double click on each component to open a dialog box.
Since the thyristors are operated at certain intervals, we need to set up the parameters for the pulse generator. Keep the time period of 2 milliseconds, which resembles the frequency of 50 Hz. We now want this pulse generator to operate for the first half of the cycle, hence the duty cycle of 50%. And this generator should make the thyristor on from the start, so the pulse delay will be 0 divided by 360 times 0.02. In this way, you can set the values for the second pulse generator. Let's observe the output of the circuit for a time period of 0.1. Click on the Run button, open the scope to observe the output. The first graph shows the output voltage 12 volt and the second shows the input voltage 24 volt. Try the same for 48 volt source. The output is 24 volt. You can see that the output voltage is half of the input voltage.